All right, here we go with a few exponents questions involving negative exponents, which can always be tricky because you're never sure exactly what to do with them because they look so weird. The negatives make you think they should be negative numbers. And so often it's a good idea when you're dealing with exponents and negative exponents to make it your priority to just get that negativity out of there. The way you do that, if you have something like this, if you have a negative exponent in the denominator, then you just take that thing, the thing that the negative exponent is on, and you move it up to the numerator. Suddenly no more negative exponent. Same thing works if you have a negative exponent in a numerator, like you see up here. You'll move it down to get it a positive exponent. And where this can be tricky for people who are first learning about negative exponents is you see in this part here, you see this 4a to the minus 1. You feel like, oh, well, everybody's always been telling me that the coefficient, that's part of the term. Yeah, it is, but the coefficient has its own exponent. It's got a little positive 1. And the fact is that's a positive 1. It's not a negative 1. The negativity of this guy only applies to the a. So when you're moving them, you only move the part that's hit by that negative exponent. So for example, here, we'll say, let's move this guy right up here. Let's do that. So our next line looks like this. 2a, I'm going to put a little positive 1 here just so we know what we're talking about. On the bottom, there's nothing left, but instead of nothing, we just always leave a 1 to hold the place there. And then likewise here, I'm going to move just this up top like that. So I have now 8a to the positive 1 over 4. And now what I'm left with is actually, this is not too complicated now that the negative exponents are out of the way. This just becomes, I'm going to simplify it to see what we're looking at. It's 2a, and then 8a over 4 just becomes 2a as well. And 2a plus 2a, you know, from way back in secondary 2 or secondary 1, that's just 4a. So that's your answer there. Once we got the negatives out of the way, it was fine. Okay, so now let's look at this next one here. In this next one, it's a little bit more elaborate because we've got a negative exponent here outside of a binomial with brackets around it. And you might feel like, well, wait, am I supposed to distribute the binomial inside? Am I supposed to distribute the exponent inside the binomial? No, you're not. First, let's just take a little sidebar and remind you. If you have something like this, 3x squared y, and then you have an exponent like this, that's what we call a power of a power, right? Then that minus 2 hits each of the exponents here like that, and that affects them, okay? But notice here inside the brackets, 3x squared y, that's a monomial. That's a single term. That's when you start hitting, like you distribute the exponent. Distribute isn't the right word, but you understand what I mean inside the brackets. In this example here, when we have 3x minus 2 to the minus 1, that's not a monomial, right? We got a minus here that separates this into two terms. So that's going to change how things work. The safest thing to do is, again, just think to yourself, okay, this is inside brackets. I'm going to think of this as a unit, like this. Almost, I could even replace it with a letter if I want. This whole thing inside the brackets is just z. So right now I got z to the minus 1, and I've got a negative exponent to worry about. So I'm going to deal with that by moving this whole thing up. So it just becomes, I'm going to write it like this, 3x to the minus 2, and now this is to the positive 1. But 3x minus 2 to the positive 1 is just 3x minus 2. So I'm going to take that 1 away from there because it's a little confusing. And now that there's nothing left on the bottom, we still have a 1 to keep track that we got something there. Okay, now suddenly this becomes less crazy, right? 3x minus 2 over 1 is a lot less intimidating than this guy here. All right, now here I got a negative exponent, and this is actually all a numerator, right? We're going to put this over 1. We're going to move our negative exponent down here, so it becomes a 2 to the positive 1. And again, the x is not being hit by a negative exponent, so he doesn't move downstairs with that negative 1, okay? All right, and then the last one over here, we have a 4 to the minus 2. Don't get distracted by the fact that you have a negative in front here that has nothing to do with the negative exponent. That minus is still just hanging out here. The 4 to the minus 2 just tells me I'm going to take this thing, move it up, and switch the sign on exponent so it becomes a 4 to the positive 2. And that means there's nothing left down here, which just means there's a 1. Okay, so all I've done here is move around negative exponent stuff, and in the case of this guy here, not move things that didn't have negative exponents. That's a double negative exponent explanation. Okay, now let's rewrite this because right now it's looking kind of weird, right? So x over 2 to the 1, that's just x over 2, right? 3x minus 2 over 1, that's just actually 3x minus 2. I could even like drop the brackets now because there's no negative or minus here, or we could just keep the brackets whatever, it won't change anything here. And then minus 4 squared over 1, that's just minus 4 squared. I'm going to write it again. I got x over 2. Now I've got like a positive 1. I'm going to burn off these brackets. X over 2 plus 3x minus 2. And this I'm going to simplify here to minus 16. So x over 2, now these guys, the 3x minus 2, they're separated now, like I burned off the bracket, right? So now I'm going to get a common denominator for these two guys. I'm going to make this 6x over 2, like that. So x over 2 plus 6x over 2 becomes 7x over 2, and minus 2 minus 16 becomes minus 18. That's your answer here. Again, the hardest part was figuring out what to do with this monster here. Once we got the negative exponents out of the way, then this suddenly isn't so crazy. Still some work to do, but not so crazy. Okay, now again for this one here, let's see what we're going to do with the negatives. We'll do those first, right? I've got a 2 to the minus 1 here. I don't like the look of him, so let's move him up here. He becomes a 2 to the positive 1 times x. And there's nothing left down here, so I just have a 1. Now notice here this is a multiplication, right? I could have just written 2x here. I put times just to remind me that I was dealing with two different terms, but 2x would probably be what I would write if I weren't trying to explain, you know. But just to be careful, this is not 2 plus x, right? That would be wrong. It's 2 times x. There's no pluses or minuses going on in this here. It's all part of one big term, okay? Likewise here, I'm going to move these guys around. I got a 3 to the minus 2. I'm going to move him downstairs so he becomes a 3 to the positive 2. I've got this whole thing, and you're saying, well, shouldn't I distribute this inside here? Let's do that in a second. Let's take care of this negative exponent first. Let's just write 6x now to the positive 2, and we'll deal with that 2 outside the brackets in a second, right? Don't need to do everything all at once. And then here I've got my x to the minus 1. I'm going to move him up here to become x to the positive 1, and the 2 just stays there. And down here there's nothing, so I leave a 1. Okay, so I've gotten rid of all the negative exponents, right? That's what happened in this line. And now let's just rewrite things so we can see it a little bit more clearly, okay? So 2 times x over 1, that's just 2x, okay? Now I'm going to distribute this exponent. People often forget to distribute it to the coefficient as well, right? That's a 6 to the 1, so that becomes a 6 to the positive 2, and I have x squared there. And then on the bottom, I have 3 squared like that. And then this minus 2x to the 1 over 1, that all just becomes minus 2x. Which is nice, because these guys, I can already see these guys are not going to knock each other out. So I just need to simplify this middle guy and we'll be good. Now it's tempting to just do 6 squared over 3 squared becomes 2 squared. That's, in this case, that'll actually work out, but most of the time it won't. So I'm going to take the time to actually resolve this exponent, figure out what it means. 6 squared, that's 6 times 6. Oop, let's move this up a little bit because the trackpad's not working. Let's move it up even further. 6 squared becomes 36, right? That's 6 times 6 is 36. So the x squared is there, and this 3 squared becomes a 9. And now I just simplify this like a fraction from secondary 1, and this becomes 4x squared. That's my answer.